Welcome to the next topic, minimization of DFA. This method is known as equivalence method or partition method. Here they have given a DFA transition table. This DFA should be minimized by reducing the number of states. This is the DFA transition table which is given. So as the first step, you will have to group the final and non-final states separately and name them as group 1 or group 2 or with any other different names. So pi naught, the partition pi naught is equal to, now group all the non-final states together, that is q naught, q1, q3, q4, q5, q6, q7, and the final state separately. Here the final state is q2. It is marked with the asterisk symbol. So it is now separated into two groups. This is, let us name this as group 1 and name this as group 2. Now make a table with all the states and the input symbol. Now the table is made with all the states and the input symbol. Now we have to find the transition, like Q0 on receiving the input 0, to which group it moves, whether whether the transition is within first group or within the second group. For this we have to refer this given DFA table. So Q0 on receiving 0, it is moving to Q1, which is of group 1. And Q0 on receiving 1, it is moving to Q5, which is of group 1. Q1 on receiving 0, it is moving to Q6, which is of group 1. And Q1 on 1, it is moving to Q2, which is of group 2. And Q2 on receiving 0, it is moving to Q0, and on 1, it is moving to Q2. So Q0 is of group 1 and Q2 is of group 2. And Q3 on receiving 0, it is moving to Q2, and on receiving 1, it is moving to Q6. So first one is of group 2, second one is of group 1. And Q4, it is going to Q7 and Q5. So Q7 is also in group 1 and Q5 is also in group 1. So it is 1 and 1. Q5 on receiving input 0, it is going to Q2, which is group 2. Q5 on receiving 1, it is going to Q6, which is group 1. Q6 on receiving 0, it is going to Q6, which is of group 1. And Q6 on receiving 1, it is moving to Q4, which is of group 1. And Q7 on receiving 0, it is moving to Q6, which is of group 1. And Q7, which is on input 1, it is moving to Q2, which is of group 2. Now we should not consider this Q2 because it is the final state, and we have to take all other pairs for comparison. So the pairs which are having the same pair value, they will be grouped together as one group, and the rest of the groups will be segregated as a separate group. Now Q0 is having 1 1, Q4 is having 1 1, Q6 is having 1 1. So let us group all these together. So Q0, Q0, Q4 and Q6. The next group is Q1, Q1, Q2 you cannot take into consideration because it is the final state which is separated already. So this is not considered as it is the final state. And 1, 2, here it is in Q1 and next it is in Q7. So mark these as a separate group. Okay, and the remaining group is Q3 and Q5. Okay, now write down these groups as separate partition and name them with different group number. So the new partition formed will be pi 1, which is equal to Q0, Q3, Q0, Q4 and Q6. Q0, Q4 and Q6. And the next partition will be Q3, Q5, Q1 and Q7, Q1 and Q7, and Q3 and Q5. Already we have Q2 as a separate group. Okay, so now take this with a different group name. Okay, this is group 3 because we have already taken 1 and 2. This is group 3. This is group 4. This is group 5. This is the already partition group, which is group 2. Okay, so now once again complete the table with the transition moving to which group we have to find, like Q0 on receiving 0, to which group it goes to. Like Q0 on receiving 0, it goes to Q1, which is of group 4. Q0 on receiving 1, it is moving to Q5, which is of group 5. Q1 on receiving 0, it is going to Q6, which is of group 3. Q1 on receiving 1, it is moving to 2, which is of group 2. Q2 on receiving 0, it is Q0, and on 1, it is Q2. So Q0 is of group 3, and this is of group 2, and this is the final state. And Q3 on receiving 0, it is moving to Q2, and on receiving 1, it is going to Q6. Q6 is of group 3. And Q4 on receiving 0, it is going to Q7, and on 1, it is going to Q5. Q7 is of group 4 and Q5 is of group 5. Q5 on 0, it moves to 2, and on 1, it moves to 6, that is of group 3. And Q6 on 0, it moves to Q6, and on 1, it moves to Q4. Q6 is of group 3 and Q4 is of group 3. And Q7 on 0, it moves to Q6, and on 1, it moves to Q2. Q6 is of 3 and Q2 is of 2. Now once again group the ones which are having the same pair. So now Q0 is having 4, 5. Q4 is having 4, 5. So they are grouped together. And then Q1 is having 3, 2. And Q7 is having 3, 2. Q1, Q7. and then Q2 is not taken for comparison because it is already separated as it is the final state, and Q3 is of 2 3 and Q5 is of 2 5 2 3. Now Q6 is remaining as a separate term. Okay, so now write down the partition. So phi 2 equal to Q0 and Q4 and Q1 comma Q1 comma Q7 and Q3 comma Q5 Q6 and Q2. Now name the group. Already Q1 Q7 is there, it is of its group name is 4, Q3 Q5 is of 5, and this Q2 number is 2. So what is the new group formed? Q0, Q4 and Q6. So it is group 6 and this is group 7. So now once again make the table and go ahead with the partition. Q0 on receiving 0 it goes to Q1 which is of group 4. Q0 on receiving 1 it goes to Q5 which is of group 5. Q1 on receiving 0 it goes to Q6 and on 1 it goes to Q2. Q6 is of group 7 and 1 is of and Q2 is of group 2. Q2 on receiving 0 it goes to Q0 and on 1 it goes to Q2. So 6 and 2. Q3 goes to Q2 and Q6. 2, 2 and 7. And Q4 on receiving 0 it goes to Q7 and on 1 it is Q5. Q7 is of group 4 and Q5 is of 5. And Q5 on receiving 0 Q2 and on 1 Q6. Q2 is 2, Q5 is Q6 is 7. Okay, and Q6 goes to Q6 and Q4. Q6 is of 7 and Q4 is of 6 and Q7, Q6 and Q2. Q6 is 7 and Q2 is 2. Now mark the groups which is having the same value. So Q0 is 4 and 5, Q4 is 4 and 5, no other term is there. Q7, Q1 is 7 and 2 and Q7 is 7 and 2. And then Q3 and Q5. So this is Q3 and Q5. So Q6 is remaining Q6 is remaining, and Q2 is the final state. So now what is the partition? So the partition pi 3 is equal to the same partition which we got earlier, that is Q0, Q4, Q1, Q7, Q3, Q5, Q6, and Q2. So which is the same groups as the previous step, that is pi 2 is equal to pi 3. So when you get any point like this, you should stop the partition. Now draw the minimized states. Using the minimized states, draw the diagram. So Q0, Q4 is one state, Q1, Q7 is one state, Q3, Q5 is one state, Q6 is one state, and Q2 is one state. Q2 is the final state, because from the beginning it is the final state. So Q0 on receiving 0, it is moving to on receiving 0, it is moving to 4 and 5. What is group 4? Is Q1, Q7. And what is 5? It is Q3, Q5. And Q1, Q7 on receiving 0, it is going to 7 and 2. 7 is group 6, that is Q6. And Q6, sorry, Q1, Q7 on 1, it goes to the group 2, that is Q2. Q3, Q5, Q3, Q5, it goes to 2 and 7. What is 2? Group 2. What is 7? 7 is Q6. And Q6 on receiving 0, it goes to 7, and on 1, it goes to 6. What is 7? 7 is Q6. So it goes to itself. And 7 on receiving 1, it goes to group 6. Group 6 is Q0, Q4. Okay, so and then Q2 on 0, it is going to Q6, group 6. Group 6 is on 0, and on 1, it goes to 2, that is Q2 itself. So this is the minimized diagram, or the minimized DFA. Thank you, students.